Hey, welcome back to another video. If you're new to my channel, welcome. If you're not new to my channel and you're a subscriber, thank you for the support. This is a little bit different type of review and also the workings of this and how to use it. This is the QIDI 3D printer, which is the way I pronounce it. So I am new to this 3D printing. So I am a complete beginner. I've had this for about 2.5 months now. I read a ton of reviews. I found out that this was one of the better 3D printers. I went high scale. This cost me 2.5 months ago $800. So basically I decided on this one because of the size of the build plate and the height that you can build. Now it comes with a full enclosure system. Door, the top is magnetic. The enclosure for the top is magnetic, and also for these sides, these are also magnetic. They go on the sides. You'll receive these, the top and the door. Now you really don't need these, and you don't need to enclose this unless you're doing ABS and certain types of filaments that require the enclosure, so that you don't have any type of draft that causes a change in temperature that ends up warping your model. So basically, when you receive this, you're going to receive it pretty much in full. It's pretty much completely set up. The only thing you have to do is you have to adjust the build plate. This build plate here, which is what the model rests on, and also this really cool magnetic build plate, this sets on top of that. It's magnet. It's got a couple of steel sections on it where they heat up also. This is what it attaches to. So the most critical thing is you have to get that build plate adjusted correctly, or else your prints will fail. I went on a bunch of different videos on, not even on this 3D printer here. Every single one of them is dead on. Your build plate adjustment is critical. You have to get it right, and you have to get it right to this actual 3D printer. It seems like each 3D printer tends to have a little bit different type of adjustment to it. Some are saying you want it a little bit domed with a little flat, or they call it a squish, a little bit of a squish. Others are saying squish it down harder. This one, you want to get it to the point where when you look at the filament that it's laying down, you want to get it so that it's relatively flat. It's not crushed in, you can't see through it, but yet it doesn't have a dome on top. And also, at least with me so far, I have yet to be able to use this printer with both filaments, injectors on it. I had to actually take one off, because as it comes across, as it's printing, the other injector will actually hit the filament and pull it off the plate or knock the model right off. So I'm not really utilizing those two colors, and one injector for the fill-in and the other one for the model. So I just took it off completely. It works a lot better for me, at least. So what they do is they do give you this, if I can snake my hand in here, they do give you this little pad right here. So this tells you how to kind of adjust it, and you will need to adjust this probably 2 times, at least 2 times, maybe 3 times when you first get this, because this, as you adjust the 2 front and then the back, it kind of throws it off a little bit. You go around the 2nd time, you're pretty much on. Just go around the 3rd, you should be dead on with it. When you're sliding this in between the build plate and your nozzle, make sure there isn't any leftover filament from when they tested it from the factory Or if you're anxious and you throw the filament in there, and then you figure out, or you find this video and you're like, oh crap, I needed to adjust the build plate. What you're going to want to do is, you're going to want to go into your settings, go to preheat the nozzle, make sure that you take out the filament, preheat it, knock off any of the filament that's oozing out, wait a little bit, make sure that the nozzle cools down. There's none, no filament left over on that tip. Then what you're going to do is you're going to have this between the nozzle and the build plate, just so that you can feel it. Because if you go too much, this doesn't give much resistance. So what's going to happen is you're going to have to look at the build plate, and you're going to have to kind of feel at the same time, because you can literally just think that you're kind of touching, but if you look at the build plate will actually sink a little bit. As this is going in, it'll squat down. So just make sure you're doing it just enough so that the two are touching this. You don't want to go too much. Then what you're going to want to do is run a test print. See what it looks like. If the print is falling off of the build plate, or if the nozzle, as it goes around, that the filament it's laying down is basically getting pulled off, you're not going tight enough on this adjusting filament here. You want to go a little bit tighter. That's basically how I figured it out, because I wasn't going tight enough. So as this injector was laying down the filament, it was either pulling it off, or as it was building up the print like this, it would come over, hit it, knock the print right off the plate. So that's one of the main critical things, adjusting the plate. So what I want to get to next is, if you're a beginner like me, you do not want to, you will get ABS and you'll get PLA. Don't mess with this. You're not going to be able to do it. It's a nightmare to work with. It's one of the harder materials to work with. Just put this aside till you get some time in with this thing. It'll drive you insane. Why get to the point where you want to throw this thing out the window when it's not necessary? Take the ABS, don't open it, just put it to the side. Get yourself some time in where you can figure out correctly how to adjust this. The slicer setting, all of the different settings to this and how everything works, so you get used to it. Then you could jump into this ABS. Now you're gonna find a bunch of videos on YouTube, like I did when I first got this. They didn't have one on the QIDI, so that's why I'm making one to help everybody out here. When you get it, you're gonna find that people are saying that this is not exactly the best build plate, yada yada. It isn't, for one reason. When you build off of this, it has a texture. Your prints will actually come out with this weird, funky texture to it, and it looks horrible. It really does. The texture on it from this plate, it looks bad. So what did I do? I went and I got glass. Yes, I tried glass. I tried it a lot, as you can see. So what I started off with was, I started off with the original glue that they gave me. That would be what you see here. See the white? That's what basically I started off with. Ran out of it, went out, picked up this one. Didn't work. Went out again, this was a closer one. Picked up this one. Worked pretty good. Yeah, so-so. So then I was getting frustrated. I went out and got liquid. Nope, didn't work. So again, what did I do? I started to freak out, watched some more videos. Hairspray. Got hairspray. This worked probably the best so far. What happened? I figured out that my build plate was not close enough to the nozzle. So I went too close. And what happens when you're too close is when your nozzle comes around like this and it comes back, what it's going to do is, in the slicer program and all, why they have it do this, I don't know. But let's say it's making the circle. It'll start the circle. It'll cross the circle. It'll start doing something over here. Then it'll cross over here, do something over here, cross over here, do something over here. And while it's going back and forth, it's actually traveling over what it last printed. If you're too close to the build plate, the nozzle will actually hit what it already printed, ripping it off the build plate, or knocking the model, if it's a small enough model, knocking the model right off the build plate entirely. It'll actually, like, I had a unit that was bigger than this, and it literally was a dual cup holder. It ripped it right off the build plate, and I found it down below, down under here. So the critical, like I keep saying, the critical is getting that nozzle correct. If it's not sticking enough, if it's hitting the filament that it already laid down, so just keep that in mind. If it's not sticking to the plate, it's too high. If it's hitting the filament, it's too low. You gotta get that happy medium. So the glass wasn't working for me. This top started to work, but I didn't like the white on the models. I didn't like the texture. Just flip it over. As you can see here, the reason why this is black, and let me get you up close so you can see it. So the reason why it's black on there is because of this. I flipped it over. And what you want to do is, you want to take the hairspray like this, hold it very far away, shake up the can a little bit, hold it far away, and just very lightly just mist. You want just a slight mist like this, just a nice slight mist. What's going to happen is, if you coat this and put a heavy coating on this build plate, okay, what's going to happen is you're going to create a high spot from the actual hairspray. And what's going to happen is, as you have those high spots all over, when you are done finished printing and you pick it up and you clean, you could actually wash off the hairspray, you'll actually see in your model, you'll see this. You'll see the different spots that were high from the actual hairspray. So you just want to get a nice coating, nice spray, and then put it in, hit the button, and start printing. So that's what I did as far as how I print and what I print on. So far, I've been using Hatchbox. Great. It's been working out really, really good for me. What you see in here right now, believe it or not, is this right now. This is a little bit cheaper. It's $18.99. I'm actually going to try the other one, the other PLA. It's I think $14.99. I'm going to try that out. But right now, this is what I'm using. It's been working really well. I get this at Micro Center. They also have microcenter.com. Hatchbox, you can go Amazon, you could go direct to hatchbox.com, but it's kind of weird because Amazon actually has it cheaper than right from the actually Hatchbox. So those are the two that I'm recommending. I've used, they worked great. I did use another PLA from some other place. It was expensive. It was like $23, and it seemed like it didn't even go that far. You know what? I wasn't impressed by it at all. I was not impressed by it. It worked, but as far as the strength and as far as the amount of builds I got out of it, it wasn't there. Hatchbox, you know, a build like this, and this is half the size of it. I've gotten 20 of these out of it so far. So far, this one here, I've gotten 20 of them out of that. So, you know, that's why I'm recommending these, because the other one was 23 bucks. I think I got about seven of these built out of it. So, not worth it. If you're new into the 3D printing world and new to this, if someone tells you, like I had a couple of friends tell me, oh, they're garbage, you can only build like trinkets or stuff to collect dust. Nope, not true. I do all types of stuff. I built this entire thing. This entire thing I actually built and designed from this printer. The internal workings of this, I printed them right out. I mean, this thing's been amazing. It really is. That's why I recommend this, because it's just been fabulous. So this little cone, all the internal workings, these two pieces, I printed them right out. So basically, and I did this too, so it will do numbers and letters and all types of stuff. In the millimeters, it's 2 millimeters. I've gotten it down to 0.90 millimeters. Comes out a little sketchy at just under 0.90 millimeters, but it's still kind of legible for letters and words and stuff. I don't know if you can see this. Let's see. Well, it's somewhat legible. This is 0.90. So, as far as everything else goes, you wanna just take your time. That's the biggest thing. Take your time. You know, don't do the dual extruder. Like I said, when you get this, you're gonna get a kit, and the kit's gonna have a wrench. It's gonna have all your tools. Get yourself a little pair of needle nose pliers. Go up under there. Hold the heating block with the needle nose pliers. With your wrench, just crack the nozzle, take it out, and then as far as this is the tube, pick which one. If you want to work with the left nozzle, work with the left nozzle. If you want the right, work with the right. For now, until you gain some experience, take the one nozzle out. It's just going to drive you crazy with it, catching the filament and this and that and oozing. It's just not worth it. And you know, I've watched a couple of other videos with, you know, they're really good people and they have a lot of time in this. Even they're saying the dual filament, it's not really perfected. You really know what you need, you know what you're doing. So just take it out for now and just have fun with it, you know. Don't sit here, try to do dual filament with all this crazy stuff, because the ABS, you're just gonna get frustrated and want to throw this thing out the window. So if you're brand new to 3D printers, this is how it works, because I was going crazy. I thought that you basically come up with something, throw it in the computer, and bang, this thing will print it out. Doesn't work like that. You need two programs. One program is the CAD program. I'm currently using Tinkercad, but I believe it's an offshoot of AutoCAD, which is an offshoot of, I believe it's Desktop or DeskCAD or something like that. So either way, I'm using Tinkercad. It's a free program. You can do all types of stuff. Like I said, I designed all this off of Tinkercad, and I did a bunch of other stuff. I mean, I've done cup holders. I've done a cup holder for our stroller. I've done little pins that hold, you know, different things. You can do a lot with this and a lot with Tinkercad. It's basically your mind. that limits you. So when you get this, and you get this, actually comes with a free slicing program. The slicing program works great. So what's going to happen is you're going to go to Tinkercad, you're going to build something. You're going to download it onto your computer. Their slicing program will take it and bring it up. Now when you bring up that model that you have to remember what you're building in here. Is it going to be more for show or something that you're just going to look at? You don't care what it looks like. If you don't care what it looks like, you're going to have your first setting. That's going to be, you know, your first layer. Your first layer, you could do, you know, 2 millimeters. You could do 3 millimeters. You could do 4 millimeters. That's what's going to stick you to the plate. Now your next one, which is additional layers, don't go higher than 2 millimeters if you're going to want to show it, because it gets very sketchy. You could see the lines. If there's any type of step up like this, you'll actually see the step up. Let's see. This is, yeah, these are all built with 2 millimeter step ups print. I have done lower than that. I did 1 millimeter and 0.90. It works, but it's a very slow print. I mean, you're talking like something like this, you're talking 8 hours. You can run into that 24-hour period on a project. So as far as the speed goes, you want to try to keep it in that 30% range for the initial say like 3 or 4 passes. Then from there, then you can step it up to like 60-65% maximum speed, and that's going to be in your slicing program. Your slicing program will also ask you what your infill is going to be. The pattern matters. So if you see this print right here, I ended up, this was one of my first original prints before I figured out what the infill was all about. Infill is your strength. Infill is also the waste of material because you're not going to see it, but it's your strength. So if you do the line, they call it the line infill, it's basically just lines, and you can see it's not strong. That's the lines. So basically what it's doing is it's making lines, and that's it. So you can, this thing is not, it's not strong at all. You could even push on the side. See it flexing? So that's lines. Now you go into basically what I've been using now, which is cubic. It's extremely strong, and it's very rigid. It's one of the strongest ones that you could probably find, but it does add more material and a little bit more time to your print, but it's going to, the strength is going to be there. So basically that's a quick view, review of this. If you're looking to get it, definitely get it. If your pocketbook can definitely allow it, get this. It's awesome. If you get the one below it without, the dual extruders, without the side panels and all, it's fine. Unless you're going to do ABS, you're going to be fine. As far as a quick tour of your display here, I'll give you a quick tour. So what you have here is your, these are your different settings, your pause and your stop. Right here, while this is running, because I do have a print going, this is your right extruder, your left extruder. I have it off right now. This is your heating bed. I have it at 50. 50 to 52 is good for PLA. This is my speed. It says 100%, but the slicing program overrides this. So this is telling the slicing program I'm allowing it, if it wants to go to 100%. I'll get back to in a second on that. This is your flow rate. I have it at 102. This is also governed by my, the slicing program. This is saying to the slicing program, I'm going to allow you to go to 102 if that's necessary. So this is where it gets interesting, because I just figured this out myself. So down here you have your RPM gauge, which I call it your RPM gauge. It's actually millimeters a second. So you're going to see it fluctuating, because depending on what your extruder is doing, that's what the millimeters per second is going to do. So if you look up here, as it's running, it's doing the infill. You're going to have it shoot up to a very high millimeters a second, 75, 80 millimeters a second. As it goes in and starts doing the outer layer, it's going to slow down, and then you'll see here in the millimeters a second gauge, you'll see it slow down, 30, 27, depending on how good of a print you wanted. That's what determines on how fast you're actually going, millimeters per second. So as far as the nozzle temperature goes, you're going to look right on the filament, or on the box to be, or right here on the box. So if you go and you see this, okay, this is temperature, printing temperature, 205 to 225, okay? Again, look at this, because Hatchbox is different. This is the inland, they're saying 205 to 225. Now if you look at Hatchbox, which I was used to when, I switched over to this, okay, this is their PLA setting. They're recommended as 180 to 210. So you got two, both are PLAs, but this PLA it doesn't even start till 205. This one tops out at 210. So just be careful, keep your eyeballs out when you start buying filament of the temperatures that they are recommending for their filament. Because if you don't print it in the correct temperature range, you're going to have a lot of problems. And like I figured out, don't go too high. Start off on the low side on the temperature and work your way up. Don't go too low. So say if they're saying 200 to 220. Go about like 205, 210, 207. The hotter and hotter you go, you'll have the stick, but you're going to have an ooze effect. You're going to look at the layers and they're going to kind of ooze down over each other, and you're not going to get a nice smooth print out of it. What else? Also, I'm sure you know by now, make sure you know what you're buying as far as the millimeters, 1.75, or they have the larger one. Make sure you get the correct one. So that's the video for this video. Basically that's it for this one. I could go on and on, but this video is getting way too long as it is. So until next time, thanks for watching. Subscribe, hit the like button if you like this video, and I'll try to get a new video up as soon as possible. Thanks for watching.